So what I'm going to show you how to do now is a basic global fit in this. And what I mean by a basic global fit is we're just going to basically assert that two fit parameters from different experiments are the same actual fit parameter. And at the same time, I'm actually going to show you how to do a blank correction. So pytc does not take blank corrected heat files, but actually tries to estimate the heat of dilution as part of the experiment. And so we'll show how to explicitly add that in this. So as we've done before, we're going to add an experiment. In this case, we'll do we'll do an imidazole titration here. It's a simple single site binding experiment, and I already know that I want to start on this second shot here. Load in those data. And now we're going to load in another experiment, in this case, the blank. So we have a blank experiment. This is, instead of calcium being titrated onto EDTA, which is our main experiment, this is calcium titrated into just buffer. And we're going to select a different model for this. We're going to select a blank model. So this is a blank experiment. Okay? Have those two different experiments loaded here. Notice they both have their own entries. Now, what we're going to do is say that the heat of dilution that we estimate from the main experiment fit is the same as the heat of dilution from the blank. How do we do that? So we click on the imidazole guy here, and notice we have our dilution heat, that's our slope of our heat of dilution, and our dilution intercept. What we're going to say is each of these is a global variable. And so I'm going to call this slope. Created a new global variable called slope that I've associated with the dilution heat. And I'm going to make another global variable here called intercept. Okay, we've done that now for that imidazole experiment. And now if we go over to the blank, if we look at these drop downs, you'll notice those new variables have been added. So we now have slope and intercept as possible options. We're going to hit slope for that, and we're going to do intercept for that. Okay? What this then means is we're going to extract a single heat of dilution from both the blank experiment and the main experiment. So we can do that fit here. We do that fit, get very beautiful, nice fit for that. Notice now we have a binding constant, fraction competent, and enthalpy here, as well as two global variables, intercept and slope, that have replaced those local variables or those individual heats of dilution from each experiment. So you can imagine you do multiple experimental replicates, you can load all of those experimental replicates in, fit all of these parameters at once.